Hi, here are a few tips for using Solr. Number 1. Use the JSON API. There are 1001 ways to do the same thing in Solr, but I find the JSON API to be the most convenient. Here's how you can index a bunch of documents. You hit the usual update endpoint of your collection, then give it a JSON array, one for each document. Notice how I do a post request to Solr's host and port. You can use curl or postman or any other tool that can do HTTP. Similarly, you can use JSON to search. Here's an example where I use the edismax query parser to search for the word document in the title field. I'm also adding a facet on the tags field. You'll want to use JSON facets because they're faster and more feature-rich than the URI equivalent. Also, I find the structure easier to read, though you could argue it's also a matter of taste. So try the JSON API, it might save you some time and headache. Number 2. For updates, reindex the whole document if you can. Solr can do atomic updates, assuming you're storing all the fields in your document. But these are expensive, as under the hood, Solr has to fetch the latest version of the document. This implies looking in the transaction log as well as in the index. Only then can it apply the update and reindex the resulting document. It would be great if we could skip all that. If you can afford to fetch the latest version of the document from the source of truth, typically a database, then simply indexing it to Solr with the same ID will be a much faster update. Number 3. Set stored false for fields with doc values true. If you sort or facet on a field, that field should have doc values true in the schema. All but text fields can have that. Doc values are Solr's columnar data structure, and if you don't have it enabled and you sort or facet on that field, Solr has to resort to field cache. Field cache is built in heap, and yes, with field cache on a lot of data, you can run out of memory and crash Solr. Now, if you have doc values on a field, Solr will also, by default, retrieve the original value from doc values. This makes store true redundant. Sure, there are some corner cases, for example fields with more than 32,000 characters in them, but for most use cases you can save space and indexing throughput by setting store to false wherever you have doc values. Number 4. Prefer multiplying boosts over adding them. Let's switch to relevance. You'll often search in multiple fields, and if relevance is important, you'll have some numeric fields to boost by. For example, the number of likes. In these cases, I usually prefer to multiply the document score to adding a boost to it. In other words, instead of using BF, use the boost parameter of your edismax. Why? Because document scores are hard to predict. So adding a fixed number to something that can range, for example, between 0.1 and 200 will have unpredictable effects. While we're at it, please avoid boosting by massive values. So I would change this to 1.2, for example. In this particular case with likes, also straight up multiplying by the number of likes is a bad idea. It will just make more popular products appear on top, even if they're only vaguely related to the search. Instead, normalize boosts, for example through a logarithm. Number 5. Garbage collection, get out of jail pass. If nodes drop out of the cluster or perform poorly, GC is one of the first things to check. If pause times are too high, it can be one of two things. You need more heap or GC runs suboptimally. If it's the latter, it's usually because GC can't keep up with the allocations, falls behind and the heap fills up. Eventually, a full GC has to clean up the heap, and a full GC takes a long time. If you have at least Solr 9 and Java 17, set GC tune to use ZGC in solr.in.sh or your environment variables. ZGC is very efficient even on hundreds of gigs of heap. The catch? Your JVM will always have 64-bit pointers even under 32 GB of heap, so you lose some usable space. Most of us won't feel that because we need some headroom anyway. That being said, do monitor your heap usage, for example with Sematext Cloud, so that you don't give Solr much more heap than it needs. Your RAM is precious for the operating system caches. Number 6. Choosing the number of shards. This is a frequent question, and the frequent answer is it depends. That's because there's no one size fits all. But here's a useful thought process. On one hand, is your data about 20 gigs or less? If it is, you can probably stick to one shard. This is the most efficient way to query because there's no scatter gather. If you need to support more concurrent queries, you can always add more nodes along with more replicas. On the other hand, with big data, you need multiple shards. Also, because each query will spawn one thread per shard, if you want to tweak for latency instead of throughput, more shards will give you more parallelism. This will be good for rare, expensive queries. In this case, experiment with different numbers of shards until you get the needed latency, but try not to go beyond 20 or so shards with default routing. You'll also want to make sure that the total number of shards per collection divides by the number of nodes. This way, your cluster is balanced and you avoid hotspots. For example, if you have 3 nodes, like I have here, 6 shards in total is a good pick. You can either have 3 shards with a replication factor of 2, or 2 shards with a replication factor of 3. You can overshard even more. For example, with 12 shards in total, you can allow adding a 4th node and move some shards around, and your cluster will still be balanced. There's a lot more to discuss, and that's why we offer different Solr training classes for different needs, from beginner to advanced, online and on-site, public or customized for your use case. Head over to sematext.com for course outlines, pricing and other good stuff. Thanks for watching and see you in class.